Good morning, everyone. We are Team Meta. I'm Karan, and my teammates are Aria, Shubham, and Krish. Our research is based on creating blueprints for cities to expand through high density infills to create socially attractive and emergent urban environments, which is centered on the idea of crafting a prototypical template for hyper programmed high density living by developing a template as a rule based system acting as a critical ingredient in vibrant city building. Initially, delving deeper into the overarching theme of this thesis, it is noteworthy to emphasize the historical significance of cities as crucibles for great civilizations and their ongoing role in shaping contemporary culture. They have served as engines for trade, finance, and innovation, propelling growth and economy. Cities have realized that their long-term prosperity is dependent on their population and economy. However, the challenges of 21st century in city building revolves around the capacity of cities to attract and retain people, particularly young professionals. And the rapid surge in the global urban population necessitates cities to swiftly adapt to this global race to attract people. The research methodology comprised 4 phases: literature, case study, design research, proposal, and forward-looking outlook. The insights gained from our literature studies are carried into the design research. We understood the concept of city as a complex of dynamic system, where diverse elements interact, emphasizing the importance of diversity not only in terms of population but also in economic activities and industries. This approach advocates for the organic bottom-up growth that considers the needs and desires of local community. We analyzed the urban grids of cities by comparing cities which are majorly divided into organic and grid. In summary of our studies, revealed that the configuration of urban fabric and transportation networks significantly influences the growth and the sprawl of cities. Tokyo and New York exemplify distinctive urban fabric and they demonstrate how such patterns contribute to varying urban densities. Further, we incorporated insights from various cities focusing on grid pattern adaptability and strategies like bottom-up generative blocks and modules as integral elements to attain high-density living. At more granular level, we scrutinize endeavors such as Marina City, Narcomfin, United Habitation, and Barbican Center. Each of these projects innovatively introduced the notion of city within a city, integrating diverse programs within their structures to foster a lively and dynamic lifestyle. Marina City was specifically chosen as our pilot case study for design research due to the successful realization of high density and diverse array of programs within a complex 2-tower configuration. To investigate further, we understood Marina City a comprehensive mix of program within a single city block. In 1960, a solution was proposed by Goldberg Architects, high-density housing and layering functions living above the shop, located in the heart of city, bringing the life back to the city by promoting high-density living. Emphasizing and highlighting by the high level of connectivity of towers sitting next to water, connected to roads and approximate to railway lines and airport. Chicago used Marina City as a model of high-density development to attract citizens and tackle depopulation in the 60s and promote city living, which was designed to accommodate 2,500 people and it was built in 8 years. And to help London increase its population, we need 140 Marina cities every year. Moving on to the research part, we started exploring self-organizing systems in order to investigate theories from one of our literature case studies of local decisions leading to global patterns. We simulated organic patterns generated in engine based on the slime mold experiments leading to organic decisions. The algorithmic logic of the slime mold was studied in the context of solving optimization problems, such as finding the shortest path between 2 points and connecting multiple points in the voxel environment in order to achieve a bottom-up system for city generation. Initially, we simulated different types of behaviors for infill strategies such as attraction and migration. And we tried to simulate the behaviors on the potential side and understood that small local actions could lead to global complexity. Hence, we use this system to deploy it to different locations in the city.
Moving forward, we understood the lack of complexity of the slime mold simulations, so we looked into more complex bottom-up approaches to the game to city design. So the city skyline as a city building games that incorporates these complex systems was a case study for us in search of urban design informed systems. As an agent-based simulation, City Skyline incorporates many of the critical urban design tools, such as a 2D land allocation, decided by the player, and then also an economic model that is used as a tool to inform and evaluate the decisions of the player. The game also provides a process of trial and error and evaluates its gameplays by 2 indexes of happiness and revenue. So a comparison of 4 urban grid strategies were tested out using this process and then evaluated based on the game indexes. So as you can see here, the 4 types of linear grid, radial, and organic city was tested out and then compared. You can see the different mix of views and also the pollution and how the city is grown on and also the transit network over time. So by tracing back these indexes to the critical factors that impacted those outcomes, we learned that the land use allocation and the distribution of the programs had a major impact on the citizen happiness. So moving toward our own game and creating a bottom-up approach to our urban design, we first chose a prototypical site in London near West Ham Station. And then further on, tried different growth simulations to test out and to achieve meshing of plots, and adaptive meshing of plots. And then we placed 3 different seed placements for each of the gameplays, so we can see different patterns growing over time. Our players, our approach actually integrates a game-based simulation for district and urban growth, aiming to achieve a mutually beneficial balance that generates advantage for stakeholders, consequently creating orchestrated yet emergent neighborhoods. So we provided 4 main stakeholders or representatives of the city players, and the 5th one would be the representative of the citizens, which would be the public player. So similarly, by adding informative architectural and urban informed rule sets, each player or representative makes decision at its turn. As an example, the residential developer's revenue is impacted by view towards water bodies and maximizing daylight, as well as keeping close proximity to office, public, and commercial units. The case, however, for office units is different in a way that the proximity to transit is crucial, and their revenue is generated towards their kind of higher connectivity to the transit networks. And also for the commercial player, as the footfall is the most crucial part, most of the units are placed proximate to other units in between, and also closer to uses the most frontage to maximize its revenue. For the public player, as the 4 players play out by every turn, they'll pay taxes to the 5th player, which would be the city player or the public player. Then the city player acts as the interval and invests in the city developments, such as creating stations, plazas, and parks to inform the city decisions over time. So here, yes, so the game starts with the public player playing in the first station and then grows over time, adding units by each player making decisions. First of all, the residential player adds up to the public spaces, the first houses are going to come, and also the transit. As the game follows forward and each player takes turns, The mix of use is also changed, and the density is configured at every step. And from these simple local rules or local actions, an emergent pattern of the city is finalized. And also this gives us a good inference that most of the office units are being placed close to the transit networks in the whole pattern as well, and the residential are closer to water bodies. We used some evaluation criteria, such as the daylights and height analysis, as well as the voxel value in total. Also, moving on further with the game, we understood that we needed an additional index to the game, so that the market demand would also introduced. For the next 2 iterations, there would be players skipping some turns, so that they play at the demand. So when there's enough population, the city player or the office player comes and plays in with him. Moving on closer, we try to find the critical decisions that made different patterns. Into the district level, we saw that we tested out 3 different initial investments. One was a distributed initial investment in a linear towards the train, and one was a massive investment in the beginning, and one was like a late initial investment by the public player. Each of them resulting in different results, and all of those revenues were then calculated at the end. Similarly, the voxel value as a collective of the values of those revenue generated by the players is shown here. So as you can see, the most valued lands are closer to the transit networks for the office, and then it impacts the higher and the later for the residential. And also it was evaluated by the daylight analysis, so it would be informed for the light as well.
The 4D land use simulation being played out on the district level corresponds to the adaptive geometric iteration. The gameplay iteration played out on district scale, creating mixed use districts, business districts, and riverfront communities. Through the 4D land use system, every corresponding iteration creates unique gameplay based on the path dependency, where different decisions taken in the simulation leads to a different geometric iterations. The other innovation research deals is with the structural system adapting to the 4D land use system while incorporating customizable architectural kit of paths enabling to its rapid physical realization. In the rule set, we assign different structural nodes to each of the program tiles. Now these assigned structural nodes reflect the program tiles' positions and functionality along the tower. For example, the contact points are spread out with 8 nodes in the commercial scenario where we require more store frontage, and with 4 nodes in the green space tile offering a more open structural system. This is one of the examples showing the node distribution and adaptation of the skeleton system as the program tiles changes along the tower. The 4D land use allocation also reflects on the facade system based on the functions and its positions along the tower.
Catering to a series of functions such as residential, office, recreational, commercial, and public spaces, we designed a catalog of parametric tiles that could aggregate to form clusters. Our first set of tile represents a residential cluster aggregation, featuring various unit sizes from studio to family units. In order to achieve high density, we chose the use of a cylinder where most of the services were towards the internal edge and the livable areas were towards the external edge for wider functions and light. Our co-working spaces were designed to promote interactive and collaborative workspaces, Each of the tiles are created in such a way that they can be combined for several functions. In this example of co-working and commercial, we can see on increasing the parameters, all the units adapt to the previous aggregation. Further on, we can see how a series of public tiles such as gyms, amphitheaters, cafes can be placed in different parts of the structure and combine.
To conclude, our proposal can become a blueprint for high-density infills, which could be applied at potential seed locations to help London double its population and economy in the next 25 years. And we would like to thank our studio masters, tutors, and Phase 1 helpers for the support that they have given to reach the project.
So here is the first outcome of the game, as was the massing, and then the bridges was later from the public player connecting these high lines all over the fabric. This was the second game that was informed with turn skip for each players. And these are the grids generated at each step of the game going forward. As you see here is the skeleton catalog. The ones that are here, like they're come from actually 5 different catalogs. So it's like from S, M, L, XLs. So as you can see, they're adaptive in 2 connections, 1 connections, and 3 and 4, based on their placement in the game. And also here we have a manual game played. As like the game, we started playing the game manually as well. So we put on the hats of each developer and we played the game, putting the units turn by turn. And a skeleton study for the podium we did previously. Thank you.
Maybe I can kick off with, well, first of all, thank you for the presentation, and thanks as well for the work. Amazing topic, quite difficult as well. I think for me, like maybe one thing that I think is quite important to understand a little bit more is not too much the kind of the rules of the game, because I think the game is so complex in a way that it's almost impossible to understand the rules. And I think it's actually the beauty. When we're dealing with the complexity, we need to kind of accept that we probably are not going to understand some things. So maybe like showing the scenario when things go wrong, you know, like what happened to the player that lose. I think they should be a little bit more explicit, so we don't see, you know, like who is actually, like what are the scenario of the losing of the game. And then a second question is the timeline, because now we're kind of, it started and built up and it become, I mean, it's the idea of the density, but then what happened to this kind of density? Is there a moment where there is degrowth, or there is even an acceleration of density and there is a new type of increments, let's say, that can be put forward?
Yeah, I agree. I think there's this question of what the extreme cases in the sort of like envelope of possibilities of the game are, and some of those could actually be related to failure. I mean, is there a case where the commercial player is the commercial layer completely fails, and so there's no more commercial space, or there's no more residential space, or what are the sort of conditions that could lead to those kinds of scenarios? And another question that I had was actually, and this is more, I guess, a clarification question, the stakeholders, they're incentivized purely, their incentives are purely their own, or is there an aspect which is also collectively incentivized? Like, are they essentially competing, or is there an aspect of cooperation to the game?
It's basically based on the cooperation. We're trying to achieve a win-win situation. So mostly each of the players or the developers are mostly a representative of that, like office developers in general. So they're playing for themselves for their own revenue, but at the end they want to have a balanced revenue of all. So the public players come within and place this intervention to create this balance to have that win-win situation. Then for us, the winning playouts or the winning scenarios are the ones that are more balanced, that all of the players can achieve a good amount of revenue. Yeah.
So essentially you have almost like a 5-body problem. And I think inevitably, in those kinds of situations, there will be sort of like dyadic and triadic relationships, which naturally form as a way to kind of, as part of the sort of equilibrium that emerges in the game. And I think, I don't know if this is explicit, but the sort of dyadic and triadic structures that you're developing here, it could be interesting if those have a specific relationship to the particular kinds of connections that might emerge between players, right? Yeah, so I was curious a little bit the circumstances under which those connections emerge. How do you decide when two buildings are beginning to become connected, or how do you decide when two different functions are converging?
It's mostly the connections are being played based on two players mostly play the connections based on the distance of these units and based on the value that is generating. So the connection units are some kind of a special unit. If you can see in the physical game as well, that are being added by the public player and the commercial player. So these are specified when there's enough distance, like a logical distance, that is instructionally informed as well. So if it's like a large distance and it's not adding to that revenue, so because each of these units have a cost, each of these players first have to, thank you, buy one of these units, buy the land, and then place that unit into that land. So the units that are having those bridges, only mostly the public player could afford them to put those bridges inside the game. Hence, most of the bridges situations that you're seeing are connecting the public uses and the commercial uses on the floor.
I mean, this aspect, basically what you're developing is a sort of function-level proxemics. So typically when we think of proxemics, it's sort of like person to person. It's sort of this at this atomic social level. But I think developing this sort of like notion of functional proxemics is actually quite interesting, particularly if you begin to think about that as having a specific transcalar relationship with the more personal kind of proxemics. So I think there's a number of different layers of interaction that could be potentially more explicitly shown between this sort of like individual, very agent-based aspect of things and the sort of incentives and motivations and actions of these sort of stakeholders. And I just mentioned one other thing. So several years ago, Brian Boygan, as an architecture sort of theorist, wrote a very interesting paper around game engines, and he talked about game engines as having what he called wild physics, this sort of aspect of physics which is not, it's not the sort of physics of the physical environment, but rather it's a kind of physics which embeds operational logic of other kinds of systems in a way that's behavioral. And one of the things that I'd be very curious about is we see the sort of like growth of your scenarios, but I also wonder what happens in the sort of like creative destruction of those scenarios, or the other sort of ways that those scenarios might evolve, which give them a little bit more kind of like quality of behavior. And in particular with the sort of like slime mold simulations, those are super evocative. I was a little bit curious why the quality of that slime mold, the sort of like differentiated scalar structure of that is not reflected in this sort of like PQ grid of these final proposals. This feels like wild physics to me. This feels like a little bit more tamed physics, like you've domesticated it in a way. That would probably be my final question, is why the discrepancy between those two?
They haven't used the slime mold.
Yeah, so it was an initial experiment that we did with the slime mold, but the problem is that in order to have that gamified version in a more voxelized situation, we needed to have like a growth which could be not a local, more like a local step-by-step growth rather than a global pattern that was emerging. So the pattern that we ended up with was having a more control over it, so that when every player plays on the game, other lands are available for each player to grow on with. But these parcels in the organic way for the slime mold simulations were not giving us that control over the grid as well. But mostly it was because
it's like the logic of real estate is demanding that you discretize it in a particular way.
Yes.
That's what you're saying. Yeah. That's interesting. I mean, I would just suggest maybe there's a possibility to revisit that interaction, because when you feel like it's impossible to apply a certain kind of system to a specific kind of context, there's an opportunity actually for some creative invention. There's an opportunity to sort of like, I don't know, not contort or sort of like demand that it conforms to that logic, but there is a possibility of thinking how it can be modified and adapted into something new. There's an opportunity there, I guess is what I'm saying. So.
I just want to come in with a few words. First of all, congratulations. I think you did a quite good job of laying this out, and I think it's a coherent project. The way you presented and the way you've resolved, showing architectural results. I just want to clarify a few points. So in terms of, you're quite clear, in terms of the incentives, it just simply laid out of the different functions what their preferences would be relative to preset points of interest, like a waterfront or a transport hub, and then secondarily that's where you can kick it off. They're also interested in each other. For instance, shops wanting to be close to other shops once they're settled in, and residents, they said, want to be close to the water, but then also maybe to offices and to each other. I mean, I'm not sure if it's fully coherently laid out, but that's for me sufficient. I'm not sure at this point why you need to talk about revenue. We don't have necessarily, and land values at this point, we don't have bidding, we just have a simple turn taking, which is an abstraction, but I think quite good to kick it off. I felt at one point was a bit unclear that you seem to be running it on the overall by having players, meaning use cases, taking the whole plot and you having a single color tower, and then later you jump to a game, and it's unclear how you transition that, where there are multi-mixed towers. It's also unclear whether you have where the heights are coming from and the depth variations. And I would have probably aligned depth with program, and then when you start stacking, you have these kind of incongruences, which might be interesting for the skeleton to take up. Anyway, I think what we discussed a number of times, in terms of the skeletons, I like this idea of that requires actually the multi-use tower to make it interesting, because where the transition from one program to another is where you have the nodes and the skeleton kind of tying together, and that gives a certain rhythm. Somehow I feel though only in some images you get a sense that you actually see the differences come through, and I'm quite glad with that. And but the correlation with the nodes isn't 100% clear, so there could be more emphasis. But overall, I think you've come. It's quite coherent. I'm quite happy with that. Even with the restrictive repertoire of using cylinder towers, using a grid. I agree, there's a fascination in these sites, which are from very, very small to very, very large. And that would open it up more in terms of different typologies. But yeah, congratulations from my side.
So thank you for the presentation. I share your fascination with setting up this complex game and trying to kind of make architects unemployed in a way that the architecture just grows. And I did that as well when I was a student, and I figured out it was incredibly difficult. And so I think what's interesting is if I look at the architecture itself, and the first thing I should say is I like your presentation style visually. I think there are some visual maturity that is quite nice to look at. I think there's some presentation technical things we can talk about in a bit, but the visuals are quite nice. But if we talk about the architecture itself, I see that it's beautiful, but I'm missing a little bit the human scale. But that is also because what you have undertaken is such a large task, right? So I think it's more interesting to talk about the method rather than the actual completely finished product, because the method is very fascinating. And that kind of brings me to the method. And the thing is, I still fantasize about this system as well, making this complicated game that runs and builds itself. And there are so many parameters. It's so complex, right? And if I think about the city developments that I think are fascinating, it's very often these older, organic, medieval, unplanned cities. And many of the beautiful scenarios of cities are the life between the buildings. And I think sometimes that also comes from not planning too much. So I think what I was missing a little bit is what is the unplanned part that creates the life between the buildings, and would that be a parameter that you could kind of put into your game? But at the same time, I'm also thinking maybe it is an impossible task. I think maybe the technique that you're doing, trying to define all the parameters manually, is just too difficult. I think maybe it's not. I think it's such a complex amount of parameters that you might need to use other methods like neural networks or machine learning or stuff like that, where we sometimes don't even know what is happening between all the different nodes, right? But I share your fascination with the slime molds. I got extremely excited when you showed that, and I would have liked to see a little bit more of that. I think just a quick presentation thing. I think it's when you were up here talking about the models, and you're not reading directly from the script, it's wonderful. There's a natural articulation. I think when you are reading, and I understand, it's also because it's always a little bit nerve-wracking to stand and present, but when you present naturally, there's some natural pauses that makes it easier for the audience to kind of figure out what is the important information and what is not. So that's just a general note. Thank you.
I also want to applaud you for the presentation. Very well done. I mean, to do such a big master plan, and actually Sarah in particular teaching this already in Vienna a long time ago, and it is very challenging. So now we are building actually one of these master plans. I mean, it's not that scale, but and there's, I think, what is a bit missing when you do these kind of master plans is you need to jump into a scale of a neighborhood and really understand what is residential and what is office buildings. I really like your analysis and how you get there, and where you place office buildings and where the residentials. But there's a lot more connected to that. It's floor layouts. It's what Patrick pointed out already, the size, the depth. Like office buildings can be only like 20 meters if you have a courtyard. And there's certain rules to that game. And so when I look at the master plan, and then there's a big jump to very clear defined facade studies. And the last model and the facade studies, I mean, the last model points out that there's a very distinct mix of functions. And when I look at the facade design, it's almost too unified. But similar to what Patrick was saying. So I think there could be a bit more variation, and that would also give you more distinctive neighborhoods. Because when you look at areas like here, you say this is all residential. That could feel very different than here, where you have high-rise buildings. But in general, I think it's a very beautiful project, and you did very well. So thank you very much.
Yeah, if I can come in, and also it's been a long process with this year, like being the first time we're trying to tackle something at this scale of a city, and think of like bottom-up processes of district formation, and how we can start thinking about computational frameworks to understand the phenomena in the first place, and then maybe intervene and formulate the role for design So in term, we set out to create a virtual sandbox to test these, let's say, hypotheses, like what would happen if, like, if there were too many residences, like, or it's too few residences, like it doesn't support the number of businesses and so on. So to that end, like, I think you've been quite successful, like to think about a bottom-up way to create order in the urban fabric. So trying to think of a master model versus a master plan, right? Like, and so I think that's been very successful. But maybe some things that I would have preferred that, like, we try to exploit that a bit more and capitalize on some of the advances in tectonic articulation, fabrication technologies that afford customization, right? Like, so like for things to be more legible in that sense, like I would have hoped that we learned a little bit more from, like, Patrick Studio, for example, like trying to map formal repertoire to the kind of program mix. But having said that, I'm very happy with, like, this is the first year, and like a lot of introspection and also a lot of literature review that we had to go through to come to some kind of coherence. So again, from my side also, congratulations. On the achievements, like, and also on the simulation side itself, like I would have hoped maybe there's, like, future work to be done in terms of, like, in terms of the payoff matrices, like inspecting what exactly happens, what are the contributing factors that might create these wild physics, as Andrew was saying, that again, so you've created a virtual sandbox, like, but I feel that you could have exploited that a whole lot more to bring out some nuances, which in the presentation got missed out. For example, like, when does the public player put the sky bridges? When does a commercial player decide to have an atrium? And so that would create wider footprint for the towers. Right now, all the footprints are relatively the same. So I think the formal repertoire is, like, quite limited, but if you had expanded that and then incorporated that into the game, like, I think there would have been a much more vibrant urban district. But it doesn't detract at all from, like, the methodological achievements and systemic ways you've gone through things. So congrats.
Yeah, I just want to say, I mean, the design is quite richly differentiated in a close-up cluster like this with 5, 6, 7 buildings. To imagine that to go across the whole field, that's where it becomes problematic and monotonous. But I do have to say, I mean, this is really bottom-up. There is, I mean, to Aristoteles, his point, this is actually not a planned city. But what there's some set of frames and constraints. It's the module menu, and then some set of rules, and then which make it which are planned, but then the play out is coming through the game. But if the set of modules is too constrained for this scale, and also the grid, I think that this would have been a more interesting choice where you have. And we have actually later on a project which uses slime mold, and I've been telling them, make the range of sites much more expanded from very large to very small and anything in between. Plus then that would come for selecting different menus. For this scale of operation, you had to be a little bit more richer probably. It works very well on this scale. I'm not sure if I can imagine it to be across this largest place. So. But I want to mention one more thing. So yes, it's not a plan. It's a bottom-up process, and that should generate liveliness, because you coming in with degrees of freedom where you see the most opportunities as people take turn. It was interesting that you said, but you have some overall proportionality criteria also, because sometimes you have to make several turns to catch up, and then others. The public comes in only every now and then. And then it's also an interesting point you're making. I like that. But one thing I think you're misdescribing it. At this point, there's no cooperation. It's a totally individual set of self-interested decisions, but invisible hand. It aggregates into something meaningful when everybody has a chance to fulfill their optimal position and settings, and that in the overall process you get everybody satisfied, and that means society is satisfied. I mean, that's the underlying premise here. And at the moment, that's I would say no cooperation in the system, and perhaps we don't need cooperation. I mean, that's another philosophical question we probably won't get into at this point.
I want to return to this question of neighborhood, because one of the things that I find, or one of the, I feel like, great discoveries of the project are these kinds of situations where how you delimit neighborhood is called into question. Because your project is not about neighborhoods at the planimetric level. It's about neighborhoods which exist sort of suspended in these matrices, right? So this is a neighborhood, or this is a neighborhood, or this is a neighborhood, right? So there's a way in which those neighborhoods also demand certain kinds of public spaces. So the ways that you've programmed the floors are monocultural in a certain way. I think actually as you begin to create these kinds of integrated structures, there's a way in which public space begins to infiltrate or metastasize through these elevated portions of the structure. So that would be an interesting sort of like next step for the development of the project. It's like, okay, well, you have this first iteration where you essentially have this very regimented distribution of program at the floor level. But then what happens when those begin to hybridize, and especially in these moments when you're beginning to connect across buildings, what are the public spaces that begin to inflect and transform how those floors are planned, and even how those neighborhoods are planned? So this question of kind of like, what does it mean to be a neighborhood in this much more spatially integrated kind of structure, I think is a very apt question for you to confront. And again, another opportunity for some fresh creation, I guess.
On that end, there's something that you mentioned or you discovered through your play of City Skyline, which I think deserves to be double-clicked on a bit. The idea that what was very interesting about City Skyline was that the evaluation was happening by actual literal human agents that have sims in that sense. They have places of work and places of where they live, and they go about their daily life. And when they go about doing that, that's how they evaluate their happiness. Like if the commute times is very long, like they have to spend, then their kind of citizen happiness drops, and therefore the happiness in that sense, the index is dependent on the neighborhood configuration. Like in City Skyline, it happens to be a 2D world mostly, but what is very interesting here is that when you have like a 3D composition, so the sense of neighborhood could be very different. Because even if you're in one tower, if you have to go all the way down and then go to the other tower, if they might be very close in physical distance, but it might actually not be as congenial for your life. So these are things that you can now speculate on, having first established the framework. So there's also a nuance of agent-based simulations that can be aggregated into these representatives, right? The stakeholders that you have, like residential community and office community and so on. But the aggregation can happen by individual agents that can also be simulated.
Can I just add another, maybe? I think just to add another point about that density and connection always come together. I think that's when we need to question it a little bit more. Density is not always the network or the connection or relation. Sometimes density also means, a bit even the case studies when you're talking about it. When we talk about the density, let's say, of a city in a tower, that can become highly isolated. So I think sometimes even to question when density is actually the autonomy of one part of one area I think is still open. I think now I find it is still based too much on the old perception of how neighborhood is constructed. It's about a kind of relationship. It's about the idea that every day I move between one building to another building. But maybe no. Maybe I live in a building for an entire week and I just live in the weekend. I think so. All these kind of questions I think are still open on the table that you can think about and explore.
Thanks, everybody.